Hello everyone, I'm Dave Honus from the Raspberry Pi Foundation, and today I'm going to be showing you how to build a 3D printed Astro Pi flight case. So to build an Astro Pi flight case, there are 4 parts that you need to 3D print: a lid, a middle, a base and a heatsink. But there are actually 7 STL files to choose from because some have multiple versions for flexibility. For example, with the lid, there are 3 versions of it. So there's one that has the 10mm holes for the flight buttons, 7mm holes for the Astro Pi kit buttons, and also one which has 3mm pilot holes, allowing you to drill to any button size that you want. There's only one version of this middle section, and with the base there are actually 2 versions. And the only difference is the position of these LED holes. For the Raspberry Pi 3, these are found on the right hand side of the SD card slot, but for previous versions they are on the left hand side. Okay, and there's only one version of this heatsink piece at the bottom, and that will not function as a heatsink, it's just for aesthetics. Let's just switch it all back on. Okay, so in addition to all these other parts, you will also need a pair of wire strippers, a pair of wire cutters, a small pair of pliers, a scalpel. Please be careful with the scalpel, they're very sharp, adult supervision is advised, a small M2 screwdriver, and then a slightly larger M3 or M4 screwdriver. Also, with your 3D printer, please read and obey this safety data sheet for your 3D printer. So there are a number of hazards with 3D printers, including hot thermoplastics and moving parts. Okay folks, so this is what we're all aspiring to. This is a genuine Astro Pi flight unit. It's milled out of solid aerospace grade aluminium, and while it looks very pretty, you won't be able to achieve something as fine looking as this with 3D printing. It's just it's a technology that's not quite there yet. So what you'll end up with is something that looks a bit more like this. And you can see that there is a kind of grainy, sort of stringy appearance to it. And depending on the kind of printer that you have, this is the kind of thing that you should expect. Okay, so there are 4 parts: the lid, the middle, the base, and the heatsink. Okay, so when they come off the actual 3D printer, they're going to look a bit more like this, and you'll see that they've got this unwanted plastic on the bottom, and this is what the 3D printer makes to level the bed that it's printing on, and also to provide support so that you don't get any bending or sagging in the plastic. And all you have to do is just use your hands, and it should just peel away. And it's quite satisfying to do this. Just slowly, not too much force. It should just quite easily come away. Like that. You don't want these discs around the edge of there either. Those come off too. Okay. Right. So that's that one done. And then this plastic you just discard. Okay, and then the same, this is with the base. All of the parts will have this stuff on them, and you just need to just slowly but surely use your fingers, peel it off. There you go. Okay. Now with the base in particular, there's a bit of scaffolding in the SD card slot that you need to remove. Okay. And you can just do this with your fingers. Just take this off. Just, yeah. Shouldn't require too much force. And you've got to make sure it's nice. That hole is nice and clear, because SD cards need to go in and out of here. You can also use a scalpel to just to help it along a bit. Okay, and that's what you should end up with. You want a nice clear hole there where the SD card can go in and out. Okay, Now with the lid, there's also a little bit of extra cleanup. on the underside of it, you can see there are supposed to be hollow pieces here which accommodate the hardware inside the Astro Pi. So I'm just going to use my fingers to try and get rid of most of it, but usually with this you need to use a scalpel. And to start with, you'll need to just dig into the plastic and just try and get it to lift up. Just pull away this zigzag first. And now we're going to go back in and just try and lift this edge up, and then it should be quite easy just to dig across the entire bottom part of this with your scalpel. Okay, so that's that bit done. And there's also these other 3 pieces here which you need to dig out, and these ones usually come out a lot easier. Okay, alright, that's that done. And then before you continue, after you've removed all of the unwanted plastic, you want to do a fit check. And this is just to ensure that you've got all the pieces that you need. So start with the base, put the middle section on. That's the bit that needs to fit. And then put the lid on and just check it for alignment and make sure that everything looks nice and straight. Okay. Yeah, that's looking pretty good. Okay. Okay, so the next step is to get the parts bag out of your Astro Pi kit, which is also available separately from the CPC website, and just to check everything that's in it. Make sure you've got the right number of parts for going forward. So you should have 6 push buttons in separate bags. You'll have 1 extended pin header. You'll have 4 50mm M4 bolts, 4 M4 nuts. You'll have 15 insulation boots, 15 friction fit crimps, which go onto the bottom of these buttons, 4 M2 screws, 4 M2.5 screws, 4 washers, a bag of 10 wires, a small length of black wire, and then you'll have 11mm M2.5 standoffs, and then M2.5 8mm standoffs, and then 4 M2.5 nuts. So in your Astro Pi kit you will have 2 camera modules, a green one and a black one, and you can only use one of them in your build process. Okay, so the green one does visible spectrum light, and the black one does visible and infrared light. Okay, so because it's slightly more scientific, I'm going to use this one. So when you unpack your camera module, you will find that it has a small sticker over the lens to protect it, and you obviously want to remove that. You don't want to install the camera module with that installed, so just take that away and just discard it. Okay. And we're going to use these 4 mounting holes to put the Raspberry Pi camera module into the case like so. Okay. Now the first thing we need to do is fold the camera module cable in a particular way to allow the Raspberry Pi to be connected to it. So the Raspberry Pi is going to sit there on top of it, and the camera connector is this one here. So we actually need to fold the camera cable in such a way as it comes up the side here and then can go in. Okay, so take your ruler and then put your ribbon like that, so that the blue end's down there and that tab's there. And what you're going to do first is just going to be 1 centimetre. So hold it over the top of your ruler like that, 1 centimetre, and then fold it downwards like so. Alright. Once you've got that there, press down. It's fine to actually just completely fold this at 90 degrees. Press it down nice and hard. Okay. Right, and then turn it like that, put that underneath, and then you're going to go 4 centimeters down, and then you're going to fold it again, but this time this way. Okay. Another 90-degree fold, press it down nice and hard. Okay. And then we're going to go there. Another 4 centimeters along this bottom bit. And then you're going to fold upwards with that bit. Like so. And then what I would recommend is that we just secure these 2 bottom folds with a piece of Captain tape. Okay. You can get away without it, but what I would recommend is that you put a bit of tape on there to stop it unfurling, and then when you're done, that's what it should look like. Now what we're going to firstly do is just remove the camera connector. Now remember that the blue tab is facing the back. Okay, so there are 2 little tabs on the side here that you can just open like that, and then the camera should just wriggle out like that. Okay. So what I'm going to now do is put the pre-made one in. Tin connector should face the front, blue on the back, and then just ensure that the tin connectors are level on the front. You don't want them in sort of at an angle like that. You want to make sure they're nice and level, and then push them closed. Push these 2 connectors closed. Okay, that's pretty good. They look pretty good. They're pretty level to me. So now what we're going to do is that's going to be screwed in like so. The Raspberry Pi will be sat on top like that, and then that can then go in like so. Okay. Okay, so we're going to install the camera module into the base using these four holes, and then they'll sit nicely on these 4 little mounting holes here. Before you proceed, just do a quick alignment check and just look through the hole at the bottom and just see the position of the lens of the camera and to see if it's off to one side or not. And if it is, what you'll find is that this piece here is actually just glued on at the factory, and it varies from camera to camera, so you can actually wiggle it like this to change its position, and you can adjust it and improve the alignment of the lens manually just by just using your fingers like this, just to adjust it. Okay, so once you've adjusted it, have another look through the hole, and you can see there you go, that looks a bit better. So now when you've 3D printed it, there won't be a thread in there, so you're actually going to be cutting your own thread with one of these screws, and what you must not do is tighten these too tightly, because the layers of these pillars are horizontal. Okay, and if you tighten it too tightly, what you can actually do is cause these 2 layers to split away and snap off the pillar. So just keep going with your screwdriver and stop when you get to the point of it feeling like it's starting to tighten. So I'm just going to use my screwdriver like so, and then I'm going to just feel it into the center, and then just slowly start to turn, and you'll see that it will go down. Okay, and that one's on. I'm not actually going to tighten it all the way up. I'm going to make sure I get all of the other screws in before I tighten it. So you see it's a bit loose now. I've got them all in. I'm satisfied that that's okay. Kind of one quick check that the lens is okay in the center there, and then I'm going to tighten it up properly. And I'm actually going to stop just as I feel it starting to tighten. There we go. Okay, and when you're done, there shouldn't be any movement. Okay, should be nice and strong. And then just check, yeah, that looks okay to me. Okay, so the next step is to install the Raspberry Pi into the base. Basically, all we have to do is just ensure the camera ribbon cable is positioned like so that it's going to come up beside the Ethernet port. and then take the Raspberry Pi and just place it onto these pillars, and it should just fit nice and snugly. There will be a bit of movement in there, but once you've installed the standoffs, it will be held securely. Now, if you've got a Raspberry Pi 3, okay, you will notice that there is this white chip here. That's the Wi-Fi area right next to where it says Made in the UK. Do not put a standoff next to that, because that will cause your Wi-Fi performance to be degraded. So what we're going to do for this particular, since this is a Raspberry Pi 3, I'm only going to install the 3 standoffs here and leave this one empty. Okay, and that should still be structurally sound enough for the Astro Pi. Okay, so what we're going to do, same drill again with these standoffs. Try not to tighten them too tightly, because you don't want to split the horizontal layers. We're going to cut our own thread, pop it in there like that, and then just start turning it with your fingers, and it should just catch, and it will start to get more and more difficult to turn. Okay, and then after a few turns you will need to use pliers to keep turning it. And do the same with the other ones, and don't worry if it's slightly at an angle. That'll sort itself out as it goes down. Okay, that one's getting tight. Okay, right. So once you feel them starting to get tight, that you can't turn them anymore with your fingers, then you're going to have to change to the pliers and just carry on. And it's usually fine to actually, if your pliers are small enough, to put the pliers into the standoff like that and grip them and carry on turning like that. Okay. So just keep going, no rush, just take your time with it. And then just as you get to the surface of the Raspberry Pi, stop turning, just as it starts to feel too tight to turn with, even with the pliers. Almost there. Okay, so that's that one done. Okay, and then just the same with these other two. Okay, that one's almost done. Okay, alright. And then remember, leave that last one because you've got a Raspberry Pi 3. Okay, so when you're ready to install the camera connector to the Raspberry Pi, just lift up this tab. It should rock back and forth. And then it's a little bit fiddly, but try and get the tin connectors in. Just work them in there, and then you want them to be all nice and level. Push the tabs back down, and then just check when you're done that those tin connectors are nice and level. Okay, so the next step we're going to do is to install some standoffs to hold the sense hat up at the correct height. Now, those of you who've used a sense hat before, you'll be thinking that you could put it directly on top of here, and you could do, but in the Astro Pi flight unit, there are these boards as well. So in a flight unit, the stack is that board goes on first, and then the sense hat goes on top of that. And to keep the flight case in keeping with the real flight case, we've made it so that that you don't need to use this board, but what we do need to do is hold the sense hat at higher level to simulate this board being there, so that the flight unit has the same shape as the real flight unit. Okay. Now you can't get these boards, we only make them in very small quantities, but basically all they have on them is a real-time clock, a crystal and a battery, and then the push buttons all connect into these pins on the bottom. Okay. Right, so all we're going to do is going to take the 4 8mm standoffs. Remember, we're going to leave the third one, and you're going to firstly put a nut on it. And these small M2.5 nuts are simulating the width of that board. They are the same width as that board. Okay. So, and once you've screwed one onto a standoff like that, you literally are going to take it and screw it into one of the existing standoffs that you've already got. Okay, and that's now ready for the sensor. And the last thing you'll do is to put the GPIO extender on. So we're going to just rip that open, pop that out, and you'll notice that it's not the same length as the Raspberry Pi GPIOs, and the reason for that is because we're going to, instead of actually having this board and these contacts for the push buttons, we're going to use the pins at the very bottom of the Raspberry Pi for the push buttons. So what you're going to do is take this GPIO extender and you're going to put it on the very top end of it, like so, and then try not to bend any of the pins, and then you're good to go. And then that leaves these 8 pins at the bottom, which the GPIO pins can go directly onto. Okay, so the next step, we'll put that to one side for a minute, and we're going to install the push buttons into these holes on the lid. Okay, so the first thing you need to do is remove them from the button bags. Just take these out. Now you will probably have red buttons in your kit, but seeing as my 3D printer uses black plastic, I thought it would be cool to use black buttons for this video. Okay, so let's get rid of those. Okay, so these buttons have 3 things on them. There is a push button which goes in and out. There is a nut which rotates, and there's also a friction washer. Okay, so when you install the buttons into the lid, you want to firstly remove the nut. Now these buttons can sometimes be a little bit tricky because the nut will get caught on the push button. It should go through quite nicely, but often this isn't the case, and you end up having to fiddle with it to get the nut off. So yeah, just requires a little bit of manipulation. Okay, like that. So leave the friction washer on the bottom with the teeth pointing upwards because they need to grip the bottom of the lid, and then just push it through the hole. Should fit nicely. And then the nut needs to go back on top. And then what I found is easier is if you hold the nut still but then rotate the button. And that will then, you'll see it start catching. There we go. That's one done. And then what I found is also helpful for later on is if you, as you tighten it, try and align the terminals on the bottom so that they are horizontal like that. Okay. Alright, so now just need to repeat that process 6 times. Almost done. Last one. Almost there. Okay, so that's what you'll want to end up with. So all of the terminals aligned horizontally like that. And that'll set us up for later when we connect the buttons to the Pi. Okay. Okay, so the next step is to prepare the wires that are going to connect the buttons to the Raspberry Pi GPIO pins, and you'll have a bag of 10 GPIO wires, and you will not have enough colours for one different colour per button, so you will have to double up at some point. So just doesn't matter what colour you choose, and they're all the same. Wire colour doesn't mean anything. So what we're going to do, these black connectors are designed to go onto a Raspberry Pi like so, and they friction fit, and you can release them like that. Now these spade connectors are designed to fit onto the bottom of these button contacts, like so. They just push on. So what we need to do is put one of these onto one of these wires. Now, we're not going to just cut it, because there's a nice friction fit crimp already in there, which could go inside that spade crimp. So all we're going to do is going to take your wire cutters, and we're going to slice off one face of this black connector, like so. Just grip it with the edge like that, and then just gently squeeze, and it should just come off like that. And then the wire should just slide out. Okay. Now, before you proceed, take one of these insulation boots and push this through the narrow end like that, and slide that down the way, out of the way. So now that metal connector, we're just going to put it inside here, and now we're going to crimp that around it with a pair of pliers. Okay. So what you want to do, squeeze gently and then alternate angles 90 degrees each time. Just keep going like that. Okay. So just check again for no movement, and then that's one done. So that will go onto the GPIO there, and the other end will go onto one of the button contacts there. Okay, and here's some I made earlier, and we need to make 6 of these in total before you go on to the next stage. So the next thing we're going to do is we're going to make the ground wire loop for the buttons. So instead of actually having 6 more ground wires going back to the Raspberry Pi, we're just going to have one which goes to one pin on the Raspberry Pi, and then we're going to daisy chain it across each button. Okay. Now in your kit you will have a length of black wire like this, so you want to just take it and unravel it like this. Okay, so we need 5 lengths. Take your ruler, and what we're going to do is use the wire snips to just cut 5 lengths of 10 centimeters. Okay, so then we are going to use the wire strippers, and we need about a centimetre, at least a centimetre of bare wire on the end of this. Now these are single core wires, so they are quite easy to strip. So just pop it in the wire strippers like that and just do that. And then you have the bare wire exposed. So you need to expose the wire on both ends of all of the 5 pieces that you've made. Okay, so let's get rid of all of these bits we don't need. Okay, so then you're going to take each of these and fold them into a U shape like this, and now it will start to become clear what we're going to do with it. Okay, so we're also going to use one of these, try and use a black jumper wire, and this is what will connect to the Raspberry Pi. So essentially what we'll have is the Raspberry Pi here, and then it'll be 1, 2, 3, 4, 5, 6 buttons. Okay, so eventually when we finished it, it will look like this. Okay. Right, so let's just crack on. So the first thing we're going to do is we're going to strip off the connector here to reveal exactly the same way as we did in the previous step. Just get your snips and we're just going to snip off that top bit and then take out that. Now, hold those two together. Now the most important thing to remember here is to take one of these insulation boots and to put it over here, because once you've got the crimp on there, you can't put this on. Okay, so just feed the narrow end in like so, and then the actual boot will do the job of holding the wires together for you. So once you've got them together like that, take a a spade crimp and pass both of them in together, like so. And what we're going to do, we're actually just going to crush it into like this. Alternate between left and right and just slowly work your way around, crushing the crimp into the connector. And what you want again is no movement in either wire. So keep going at this until you've got a really snug fit. Can be a little bit tough on your fingers. Okay. Right, and then just give it a wiggle. Just to see how it moves. Okay, that's pretty good. And then when that's done, just slide that back up and into there, and that one's done. And we're on to the next one. Okay, so when you get to the end one, what I suggest to do is to take your pliers and just maybe strip it off a little bit longer, and then fold it over so that you make a double width of the wire, and that will be what you put into the insulation boot and then the crimp. Slide that back up and we're done. Okay, so what we're going to do now is we're going to connect our ground wire first and followed by our GPIO wires. So the ground loop is going to go to one side of each button, okay, and the most optimal path that I found is to start on this button and go 1, 2, 3, 4, 5, 6. Okay, so to start with, let's slide these insulation boots back down on the whole wire. Gives us more purchase on the terminals. Okay, let's just do that for them all, and then we'll put them back up as we go. Okay, so start with the very end one, and we're gonna go onto this button here. So between finger and thumb, just literally hold it together with the button terminal and just push, and it should just go on. And then once you've done that, you can slide the insulation boot back down into its final resting place, and then just work your way around. So let's go for that one, and this one. And this one. Okay, so that's now ready. So now all we need to do is put these wires on. So one per button for these wires. And it doesn't matter, they're all any colour, doesn't matter. Do one final check that they're all on there, all nicely torqued. And then to keep these ground wires out of the way, you can just fold them neatly down like that, out of the way. And that's not going to cause a problem, that's fine. Okay, so that's now ready for the next stage. Okay, so the next step we're going to do is connect these GPIO wires to the Raspberry Pi pins here. Now, if you orientate the Raspberry Pi as like so, with the Ethernet port and USB ports facing down, the GPIO pins will be on the right hand side, and then that represents this diagram. Okay, so this red box indicates the pins that we're going to use, and they're all located at the very bottom end of the header here. Okay, now before you go any further, before you actually connect any wires, fit the middle section of the case. Okay, and that fits over this like so, and it should just click in. Okay, now if you don't do that now, you won't be able to do it later. Okay, so firstly let's start with the top button. The top button is GPIO 26, so you find GPIO 26 on here. We're looking at this top button, the up button. GPIO 26 is that button there, so you basically follow the diagram, pop it on like so. Okay, then I'm going to do down, which is this blue wire. Okay, and that is GPIO 13, which is that top one there. Okay, and then we do this one, which is actually the right push button but left for you, and that's GPIO 19, which is in between those two that I just did. So let's just put that on there. Okay, right, let's do now this is the left push button but on the right for you. So that is GPIO 20, which is this one. So that goes there. Okay, and then you've got these just the bottom two buttons, A and B. So this one is the one that's on the left for you, button B, and it goes to GPIO 21, which is this very bottom one here. Okay, that goes on the bottom there like that. And then this one here is GPIO 16, which is on top of here. So GPIO 16 is that one. Okay, and then the last thing you do is ground, which is that last ground, that black one, and you can either use this one here or this one here. Okay, I'm going to go for that one on the side. Okay, and then do one last check to make sure they're all the way down. Okay. It can be a bit awkward when you close the lid, so you are now at the stage when you want to close the lid, so you can basically just try and scrunch everything down in there. Like so. Okay. That's basically how it's going to go, and then they're all directly already connected. Okay. Okay, so the next step is to install the sense hat and screw it down. So take your sense hat, and on the bottom of it you may find it comes with this connector which you can then remove. So in between finger and thumb, just hold it like that and wiggle it left and right, and it should come free without too much effort. Okay, just like that. Okay, now that's the orientation that it goes on, with the little notch towards the front of the Raspberry Pi. And what you're going to do is you're going to line up the very first pin of that with the very first pin of this header. Okay, so you want it to just fit on there. It could be a little bit fiddly at this point just to get it to line up correctly. There you go. And then push it down. And what should happen is the pins should not actually protrude with any height above there. You'll feel them if you touch them like that, but they shouldn't have any kind of height above the sense hat. Now take the M2.5 screws and just screw the 3 standoffs that we've got to secure the sense hat. Okay, right, and then we'll do a fit check just to make sure that we're not impacting anything. So try and close these all in there neatly. And there we go. Okay, that looks pretty good. Okay, we're almost ready. Okay, so just neatly tuck the wires in as you close the lid and make sure that's all okay. Then you need the heatsink. Put that onto the heatsink. Okay, you just want to make sure that this entire flat plane is all nice and lined up and that the 2 holes on the bottom are lined up. And then what we're going to do is insert all 4 corner bolt enclosures. Okay, get them all through. We're not going to do them all up straight at the same time. Just try and make sure that they're all reaching right through. Okay, right, so those are all in. So what I found is the best way to do this is to actually put a bolt with between finger and thumb along the bottom of this, pushing that nut up slightly, and then use a screwdriver to turn the nut, to turn the screw head. And then you can feel it pushing through below you. Okay, and you see it coming through there. So just do that for all 4. Okay, so there we have it. So not quite finished yet. I think basically once you've done that, you've just checked the alignment. You might want to just adjust the top slightly to make it so that the LED matrix is perfectly central. And then you can just use finger and thumb. You have to stop that nut rotating, and then you can tighten it up really good. Okay. Okay, and also don't forget that you can 3D print the joystick there, which is another file that you can download and just pop it on. Okay, so there you have it, the final fully complete Astro Pi flight unit. There it is compared to the actual genuine flight unit, and you can see they are almost identical in their shape. So, and what you've now learned is quite a lot of nice knowledge about the internal makeup of these computers. Okay, so next task is to boot up and test. Okay, so firstly, SD card. Pop that in there. Okay. USB keyboard and mouse. HDMI. And lastly, power. Okay, so when you get to the desktop, if you've got an ESA branded Astro Pi kit, you will see the ESA logo as your desktop background, and you should just find that everything will work out of the box. So you can go up to the terminal icon up here and click it, and then if you just push your push buttons now, you'll get up, down, left, right, A, B. Okay, so it's typing letters. Okay, now if you on standard Raspbian though, this won't be working yet, and you'll also still be looking at the rainbow pattern on your LED matrix. So for you guys, there are a few extra commands that we need to type in. So let's go to Chromium. Okay, and Astro Pi website, astro-pi.org. Okay, and then we're going to go up to Learning Resources, and then Astro Pi Guide. Okay, and we're going to scroll down to Inputs and Outputs and click on Buttons. Okay, now you can ignore most of this, just scroll all the way down and you're looking for a heading called Detect Button Pressing Code. Okay, and all we're going to do, we're just going to copy and paste some of these commands that are here into our terminal window and run them. Okay, so this is downloading a file we need to enable the buttons. Okay, that's that done. And then we need to just edit the config.txt file, which is kind of like the BIOS of the Raspberry Pi. Just paste that in. Now when you come in here, you don't need to touch anything, just scroll all the way down to the end of the file. And we need to add these 2 lines here. Now if you've already got an Astro Pi kit from ESA, you'll already have these lines. Otherwise you will have to type them in. Okay, so just type them in and then press Control O and then enter to save, and then Control X to quit, and then you would go sudo reboot. Okay, but I'm not going to reboot now because I don't need to. Okay, and for everybody now, do this one last step, which is to run a little test program that just verifies that we've done everything correctly. So copy this, go to the terminal, paste it, and then run pygametest.py. Okay, and then this blank window will come up and you can now start pushing your buttons and moving your joystick. Firstly, joystick, so down, up, left, right, center. Then you've got up, down, left, right, A, B. And that's exactly what you should be getting if you've done everything correctly. Okay, so up, down, left, right, A, B. And then the same with the joystick. Well, that should just work no matter what you've done with the buttons. But right, left, up, down, A, B. Okay. Okay, so you saw there that I went to the Astro Pi guide on the Astro Pi website there. There's lots of other resources online there to help you learn about Astro Pi, so please make use of those. There's also an Astro Pi forum. If you can't find the answers that you need, there's a forum where you can go and post your own questions and someone will reply to you with the answer. There's also a really good Astro Pi FAQ on the website which you can read. It has most questions already answered that you may come across. And yeah, have fun learning, enjoy yourself, and good luck with getting your code on the International Space Station.